Hey everyone. First of all, thank you for coming and welcome to From 0 to 100 Fine-Tune All the Things. My name is Pablo Guardiola and I work at Mapbox in the Android Mobile Navigation SDK team. And today we are going to talk about all the performance work that we have done working on the Android Navigation SDK. I want to give quick props to my friend Dan Nesfeder. I prepared the talk with him, but he couldn't make it today. So I'll be walking you through all the ride that we did in order to create or build this pipeline, which is going to help us track performance over time while changes land into the SDK. Oops. There you go. So just to give you an example of poor performance, this is one of the UI components from our SDK. We are offering time-and-time navigation. And as you can see here, we are having like a bad experience, right, from a user point of view. The animation is not fluid. The pack, showing where you at is jumpy and choppy, and especially like in the context of building a navigation SDK, you need to make sure that the users give like the whole context, right? We want to make sure that the developers and end users know where they at all times. And at this point, this is not the case. And because having like a performance like this will mean that some drivers could miss a maneuver because they don't know where they at. So this is definitely one of the things that you need to take a look at for your applications or SDKs. So I want to give a quick overview of the pieces that form the navigation SDK. And the first two ones are maps and location services, which probably you are already familiar with. This is another example of rendering a map, and then on top of the map we are showing like this blue dot, which is basically showing you where you are at that point. And you can think that well, this is easy, right? We have like this other maps SDK which exposes like this location component, but it is not that easy. It's not only like a map rendering. Actually, what we are doing here is creating like this custom layer in order to draw like the pack. And of course, at the same time, we are hitting the GPS radio every second. So we need to make sure that everything is in sync. And of course, we need to give good performance so this doesn't look weird. Another important piece of the navigation SDK is routing, right? You can think about this like we need to know like the instructions and all the information that you might need to be interested in from going from point A to point B, right? We have this other service at Mapbox, which is the Directions API, and this is giving us back all the information that we want to expose to the developers. This is another example of hitting that request, and then, as you can see, there are like these blue, yellow, and red portions of the route, which are like showing the congestion and the traffic. So this is not just only like doing a request to an API and get the response and then draw something. It is more than that. It goes beyond that in the sense that we need to get that information, parse it, and then at the end of the day, render it on top of a map, which of course, we need to make sure that it is fluent because, for example, imagine that you are trying to go from DC to San Francisco. This is going to be like a giant response, and you need to make sure that you serialize all this data, on time, right? And you don't block the UI and again, you think about like how you are performing. And finally, and probably like the most important part of the navigation SDK is route processing. And all the, as I said, all the information needs to be processed really fast. Ideally every second. So you need to make sure that all the things that you are doing are within a second. So you give like a good experience to the developers. And this is basically what navigation brings together, right? And here you can see a good example of the navigation UI. Which is basically telling you at the proper time that you need to go right on Clifton Road, and you need to make sure again that your users get like the whole context and a good navigation experience. So now we need to look at what areas of the performance we need to take care in order to create like a pipeline that does this, like track performance over time as changes land in the SDK. So again, we are a small team in the navigation SDK, so we don't have like this dedicated team that can work on this, the whole time. So we need to also like balance our time and resources with other feature development. So the idea here is that I want to say like we need to have ways to automate this as much as possible, so we can basically, implement this once and then forget about it, and have some kind of mechanisms that will, warn us when something goes over some threshold that we are moving on. So then, when we started this exercise, we, first of all, we ask ourselves which performance areas are we interested in, and of course, we are interested in knowing how we are performing in, on the CPU. Like what percentage of the phone cores are we using? Then memory, it's another concern that especially like, like OOMs are definitely a problem for some users, and especially like for the lower end devices. So we need to make sure that we are reducing our amount of resources, and that we are not the cause of the system shutting down some of our services. Then, of course, we are also interested in knowing how we are behaving in terms of bandwidth and data consumption. As I said, we have different APIs that we need to hit the network, including, as I said, like the directions API, map tiles, and voice instructions. So, and right now, like data plans and phone carriers are expensive. So we don't want to end up like being the problem of costing that amount of money for our users. They basically don't need to worry about like these kind of performance issues. And of course, and as you have seen, battery is right now a concern, right? This is basically probably the most obvious thing that your users are gonna be checking. Of course, because if you are introducing like this drainage of a battery from the SDK, this is gonna be really bad for you. Actually, if you are in an SDK company, that will mean that you will be trapped out, and maybe your customers choose another provider. And all these three top items can come into play together, because at the end of the day, the battery is what is powering the rest of the areas that we've just mentioned, like CPU, RAM, and bandwidth. So how did we started doing this effort? Of course, one of the first tools that you look at, especially if you are an Android developer, is the Android Studio Profiler. And I don't know if you have seen like the talk from Sen this morning, but this is going to relate as well, and I'm gonna discuss like all the pros and cons that we found or we ran into with this approach. And one of the benefits is that you can get real-time and readable data. And I don't know if you have ever used the Android Studio Profiler. By the way, how many of you have watched previous talk this morning? Not that many. And how many of you have used before Android Studio Profiler? Okay. But yeah, so as you can see here in the example, this is the same example that I showed before. We have at the right what is going on when you start up your application using the SDK, and you can see basically on real time what is going on, which is huge, right? And then another good point is that this is showing us the areas that we were interested in, which are CPU, energy, memory, and network. Another benefit here is that the profiler is giving you this feature, which is the session recording. And this basically allows you to compare, right? For those of you that weren't this morning in the talk, but Sen was saying like you need to basically set a goal, right? Which in our case is like having all these different areas to be benchmarked, and then you need to do some changes, get the results, and then repeat that again. So you get the results, and then you can compare. So this like with this feature, you can do that. You can basically record a session, see how it goes, and then after that, do some changes and see if you have some gains or if where are all the like hotspots. Another good thing about the Android Studio Profiler is that it gives you this detail and analysis. And when I say detail, it's like, you know, as per method basis. You can go, you know, to the method that is causing you, you know, this problem. But we determined that this is great for an initial signal, right? But it kind of ended there because does this solve our initial problem of, you know, tracking these performance metrics over time? And the answer is no, because of these drawbacks that we run into. First of all, you cannot download or send any recorded data out of you know, the Android Studio, and this is basically, you know, something that we didn't want to. And again, I would like to talk to Sen if there are any possibilities to extract that data out from Android Studio somehow, so you can automate and you can, you know, get the same numbers that the Android Studio is showing within the profile. Another drawback is that the Android Studio resource consumption. This is more like a productivity blocker. What we found is that as soon as you start up the Android Studio Profiler, everything freezes. And that's, you know, this is not something that we can do. We don't want to, you know, sit down and wait for all the tests to finish. Because, as I said, we also have other like priorities to work on. Another problem that we run into is that the Android Studio Profiler only works for API 21 and above. And just for give you context, Mapbox SDKs support API 14 and above. And especially, you know, if you think about this, it's like normally those lower end devices that are running in these smaller APIs are more a concern, right? At least on terms of performance. So we needed to find another way to test also, you know, these other APIs. So we, you know, work around this kind of blind spot. So what did we do in order to, you know, work around or, you know, follow a different approach? What we thought that it would be great was to create like these custom test rules. One quick question: how many of you have used like this kind of rules before in your test? So. Good. So you don't know what a rule is. So let me explain you what a rule is. Basically, this is the ground permission rule from the support library, which if you have a test that you know, handles some like location permissions, you will need to go over the whole flow of granting the permissions in order to just execute a test. And you don't want that, right? Because this is like a bunch of boilerplate, and because of that, these rules are included in the support library, and basically what it's doing is, you know, like implementing this code for you, so you don't need to care about like all the flow to get the location permissions granted. So the idea here is that with this kind of idea of using like these custom test rules in the same fashion, we will be able to have like a reproducible test, which was kind of a profiler drawback, because we will have these custom test rules to basically generate the data and store it to the device, so we can then pull out from the external storage and then send it over to our data warehouse. And this is just an example of one of our tests that is running 3 times. And probably one of the most crucial points, right? Because this is just at the beginning of a startup, the navigation component. And this is when you are basically requesting the route and initializing everything. So it is something that you want to see how it performs. Another good thing about these custom test rules is that you can record and store the data, which as I said, is something that you want to have if you want to track this over time. And with what we finally ended up is creating these rules that basically are doing like these 2 steps. And for the before case, what we are doing is that resetting everything. So we have this starting point, and we are using this DAMSys tool. By the way, how many of you are familiar with DAMSys? Not that many. Okay, so DAMSys is basically a tool that gives you a bunch of information, like in terms of performance. You can get the battery stats, you can get the CPU info, and like graphics and other stuff. But here, what we are doing is, utilizing that in the UI test in order to generate all the data in which we are interested. And then we have like the after part, which is basically retrieving all the information that we need, and then storing it into the external storage. This is just an implementation example of how we abstracted these custom rules. So we are using this specific CPU info service. But at the end of the day, what it's doing is, behind the scene is doing this ADB self DAMSys CPU info command that will give you this like giant text file that we'll talk in a minute. Another thing that we needed to take into account was how are we going to execute this like in a regular manner, right? And in order to do that, we needed like this device farm that allow us to basically store something, and when the tests have finished, be able to retrieve all the data generated. And unfortunately, the Firebird test lab doesn't allow you to do that, or at least that easily. I talked to Sam yesterday, and there are some hacky ways to get the data from the external storage within Firebase Test Lab. But we ended up like going with the AWS device form because it's more user-friendly in that regard. But again, does this solve our problem? And let me explain you some of the drawbacks that we found with the custom test rules approach. Of course, you know that creating UI tests is hard. You know, you can see that most of the documentation and the test pyramid, we have like UI tests at the top, which means that these are hard to you know, implement. And that was hard for us as well because you need to make sure that your tests are reliable, right? And especially like if there are like different components involved. Another problem that we ran into was that this takes a lot of time, especially in our case. We have like these control routes that go from 2 minutes up to 10 minutes. So if on average, that would mean more or less like 5 minutes, which means that if we want to run this 30 plus times, that will be like 2.5 hours, right? So this is a lot of time, and that's another problem that we run into. Another thing is that the DAMSIS output isn't easily parsed. You know, there are not that many documentation of what you get from DAMSIS. And just to give you an example, here, this is like what you get when you execute the CPU info DAMSIS command, right? And we were only interested on, you know, this the third line, which says 225%, right, of usage of the CPU. And where is that 200 like percentage? How does that work? We actually, you know, needed to find that out, and it seems that this is based on the number of cores that your device has. So then you need to also divide, you know, by the cores that in which you for the device in which you are running the test. And then forget about the rest. But we needed to take that out somehow, which was the number in which we were interested. And sometimes output data can be, you know, unreliable. We found out that, you know, especially like for the battery stats, we found out that, you know, when we ran the same test with the same scenario a couple of times, we were getting like, you know, missing information or, you know, like weird information that was, you know, putting, you know, some of problems to us in order to get like meaningful data. Then, okay, we thought that, okay, this is good. This is how we spend like most of the time. But there is also like the possibility of, you know, introducing like this production telemetry, if you will. And this is good because this will give us like signal from real world usage. That means that you are not in a test lab anymore. So meaning that your users, you know, are like real usage, right? That are, you know, using the app or like utilizing the SDK in many different ways. Which means that we are gonna get like a larger data pool, and we are meaning that we are gonna get more data and faster. And of course, we are targeting more devices because even if you are using a device farm, normally those are limited by the different devices that are available. But again, does this solve our problems, or what were the drawbacks that, or the cons that we found? Of course, this is a production environment, which means that you need to make 100% sure that the code that you are introducing is not going to add any extra overhead, just for the sake of gathering some performance metric. That will be funny, right? Like you will be ended up shooting into your foot, right? Yeah, so you need to make sure that you are not introducing any extra overhead. And the same thing happens with data consumption, right? At the end of the day, you need to gather all this information, but you need to send it to the data warehouse, which means that you need to somehow send this data over the network, and you need to balance how you do that. And then data normalization, in the sense that as you are getting like different data from different devices and different operating systems, you need to get some amount of data in order to get like meaningful and statistical insights. Now let me walk you through the process that we implemented. First of all, we implemented like this test suite that I just mentioned, which is based on some custom rules. Then we define like these control routes, and then we generated the data. After that, we need to process the data, which means that we need to retrieve the data from the external storage, and then parse the data, and finally send it back to the database. And then, of course, what you need to do is to analyze that data, which means that you need to query that data, maybe filter it out, and then presents the results. And that's it, the fruit of our labors. And as you can see here in this graph, we are showing the average Java memory consumption over the different SDK versions, right? And the good part about this is that, as you can see here, we can say that we have like this range that in which we are moving on, like from 6.5 to 7, more or less. And the good thing is that we need to implement like some mechanism in order to know when we go over that range. And at that point, that will be warning us when we need to do something, or when we introduce something that is not good, and we can do this pre-release. Now let me show you the pipeline. This is more like kind of an implementation of the process, but we need to first of all like prepare everything. So you might need to have a trigger for your CI, which will pull the code, build the SDK or the app. In which, in our case, we have 2 flavors of the SDK, so we needed to create like different versions for both of them, and then we need to assemble the apps, like both the regular app and the test app. Then we use, as I mentioned, AWS Device farm. So you need to upload the apps, then run the test. Then we have this kind of a script that is polling for when all the test suite is completed, and at that point you can retrieve all the test files that were generated, and then download them. And then So I mentioned we have these scripts that are mainly Python scripts to parse the data. So basically, we are extracting the data from the DAMSys files that I showed you, and then we are sending it over the data warehouse. And then we are using mode, in which we need to write some SQL queries, and finally building some reports. And what's next? Of course, as I mentioned, we are a small team, and we took like this exercise as an ongoing effort. So there are like a lot of room for improvement, and one of the things that we need to keep investing is in more automation. There are some parts of the process which are right now, manual, and we, as I mentioned, what we want to do is like, basically automate as much as possible, so we don't need to, maintain like this, other than when we find some hotspots. Then there's this concept of triggers thresholds. As I mentioned before, if we know all the ranges in which we want to move on, we need to implement like mechanisms in order to be notified when something goes over those ranges. Then feature flags. This is something that it is especially needed if you are taking the production telemetry approach, because maybe you are introducing this kind of overhead, especially like when you know that when you are instrumenting things, those normally are heavy. So we need to have mechanisms in order to enable and disable this kind of features, or enable it, as a customer request basis. And to summarize some of the takeaways, of course, performance is important. I mean, whatever involves money, I think it's important and should be, taken into account. And another thing that we saw is that it's tricky. There are not that many information, and you need to extract the data out. You need to spend a bunch of time, like creating this UI reliable tests. And another thing is that it's an ongoing effort, especially like what we are doing is iterating as much as possible, getting feedback, see what we could improve, and move on. And then you need like a good amount of data. And I remember like being in a talk, like which the topic was machine learning, and the speaker was talking about like billions of samples. So this is not something that you can basically run 100 times and you can start like making conclusions. In order to get like meaningful statistical insights, you need to have hundreds or millions of samples. And that's mainly it. I think that we have 1 minute for questions, and yeah, thank you. Oh, just a quick, reminder. If you like what I've just showed you, we are hiding. Please ping me, grab me. I'm more than happy to help. And one last thing, I'm also one of the DC Kotlin organizers. So if you want to talk at a Kotlin meetup, please reach out to us and let us know, because we are always looking for speakers. Thanks. There was a question. Yeah.
Yeah, I had one quick one.
hold on.
I see you're doing dump sys before and after, but what if you have a lot of complex stuff in between there? Like, is the dump sys after going to capture that, like any heavy calculations in the middle?
Yeah, that's the idea. So you have, this starting point. So you reset everything. Then you run, of course, whatever you are benchmarking, and then you get the results back. What we have saw that we have been seeing, like in some situations, if you try to run this really fast, or especially like for battery, it seems that in order to start like getting data back, it needs to wait more than 10 minutes and things like that, because as I said, this was like this unreliable use case that we ran into, in which we were seeing like no data when it didn't make any sense. But it's tricky because you cannot rely on it like 100% of the times.
So I know that you have the API format Mapbox, so usually when you test it like for performance, like segregate out the API performance and the
What API? Sorry.
So like I have seen that you have APIs that the other developers can use.
Yeah.
So do you all, when like you're testing it for the performance, is it like separate for APIs and the app that you're using it to integrate and test it?
What do you mean? I'm not sure if I follow.
So like if I'm a developer that's trying to like use your APIs,
Yeah.
and on my own app, so you might not know the performance of how my app is working on. So when you're testing the performance, you have to like, it will be used as an API in your testing app also. So will you be like segregating, okay, this is an issue from the app side or the platform, and this is an issue from the
Yeah.
API. So you all have that segregation in scripts, like will your scripts do that?
We don't have those, but what we are trying to automate first is like the use case that we control, which are basically the areas of the SDK, right? So as I mentioned, we have all these control routes, and basically what we are aiming to do is like isolating as much as possible, so we know for sure that like in the regular use case, if there is like a bottleneck or a hotspot that is coming from us, so we know, so we can basically address it before releasing a new version of the SDK.